Now we need to derive Slutsky equation mathematically. We have the compensated demand curve or Hickson demand curve as given by, or Hickson demand curve is given by, say, Hx, which depends upon Px, Pu, Px, Py and U, assuming that there are two commodities X and Y and U is the utility. Now an ordinary demand curve is dx, Px, Py and U. Okay. Now if you want to achieve a given level of utility, so what is the minimum expenditure which you need to make? For that we have an expenditure function. Okay, so we have the expenditure function which is Px, Py and U. So expenditure function is actually EPU, which is the function of prices and utility, where utility is being kept constant. So then in case if now the point is that compensated and ordinary demands would be equal in case income is exactly what is needed to attain the required utility level. In case if income is exactly what is needed to attain a required utility level, in case if I want to achieve U bar and income is actually equal, exactly equal in both the cases, then we say that your Hx, Px, Py, U is equal to dx, Px, Py, U. Okay. I can even write this as, I'm sorry, let me just rub it. Okay. Yeah. So Hx, Px, Py, U is equal to dx, Px, Py, and in place of U, that is the minimum expenditure which is required to attain that utility. Okay, so that is equal to your EPU. So that is EPU. So in place of U, you're writing EPU, that is Px, Py, U. Okay, so now this equation is actually, I mean, how you have obtained this equation is by inserting in place of U EPU. Okay, now in case if you partially derivate this with respect to Px, what is it that you will be getting? Del Hx by del Px is equal to del dx by del Px plus del dx by del E into del E by del Px. So this is the way you will be partially derivating this expression, okay, in order to get this expression, that is your del Hx by del Px is equal to del dx by del Px plus del dx by del E into del E by del Px. Now if you rearrange this in order to get del dx by del Px, you can get this form, that is del Hx by del Px minus del dx by del E into del E by del Px. Okay. Now try to see these two terms, that is important. Del Hx by del Px. Okay. Now in this term, it is the, what exactly is this? As you can see, Hx is the compensated demand curve and we are just trying to find out the slope of this curve. Okay, so this is just the slope of your Hickson demand curve or compensated demand curve. But you remember this, that along this curve the utility is being kept constant. Okay, and since utility is being kept constant, so in case if you move along the slope, okay, along this curve, whenever the slope is going to change, so what you're going to get is something called substitution effect. Okay, so this term is showing you the substitution effect of the price change. This is the total effect of the price change. So del dx by del px, that is when the price changes, what is the demand? So that is the total effect of price change. Clear? Now about this term, have a look at this term, that is del dx by del e into del e by del px. It reflects the way in which the changes in px affects the demand for x through changes in the necessary expenditure levels. So what are going to be the changes in dx? Okay, I mean changes in demand with changes in p with the necessary changes in the expenditure level. So this term is actually reflecting your income effect. Okay, this is your income effect. I'm again repeating. It reflects the changes in px. Okay, reflect the way in which the changes in px, when your px changes, how does it change the demand, keeping the necessary changes in expenditure. Okay, now this is your income effect. Okay, this is your income effect. Fine. So while the negative sign, it shows the direction of the effect. It could be positive, it could be negative. Okay, now for example, in case if px falls, okay, in case if the price of x is falling, then the expenditure to maintain that utility would also fall. Okay, suppose you need to maintain the utility at u, okay, and you need to um, and when the price of x was say 5, okay, so it means that, and you're buying 1 unit of commodity, so how much you're paying in order to maintain that utility? 5. Okay, now you need to maintain the utility 5 only. Okay, but the price of x has fallen to 2 and you're still buying 1, so you need to spend less. Okay, you need to spend less in order to maintain the utility level. So if px falls, the expenditure level required to attain a given level of utility also falls. The decline in x that would normally accompany such a fall in expenditure is precisely the amount that must be added back through the income effect. Okay, so this is in that case your this would be your income effect, and it could also be the case that suppose in case if the price of x increases, okay, then in that case the amount of expenditure which you need to make in order to keep the utility level at u, it will also increase. Suppose if from 5 it increases to 7, okay, so the amount of expenditure you need to make in order to keep the utility at u would be 7 instead of this. Okay, but because the nominal income is in fact, I mean it is held constant at on the Marshallian demand, so these extra expenditures are not available, hence x and y must be reduced to meet this shortfall. So what you actually understand, what you have to understand is this, that in case if you are given any Hickson demand curve, then from that you can probably find out what is your expenditure function. Then you can even find out what is going to be the changes in the demand for a commodity when the price changes, and that change could be broken down into what is called substitution effect and income effect.